So you'll see that the properties we're going to study are very similar to the properties of exponentials. We have rules, in fact, that mirror that completely. So the first one that we should look at is what happens when I try to take the logarithm of a product of two things. What we see is that the logarithm of x times y, given here, is equal to the logarithm of x plus the logarithm of y. Okay, so products go to sums. Whereas for exponentials, when I had the exponential of a sum, it became a product. Okay, so it's somehow inverse of that. A related rule is not what happens when I take the logarithm of a product, but when I take the logarithm of a quotient. So a similar game is played. The logarithm of x over y, seen here, becomes subtraction outside of the logarithm. This is equal to the log of x minus log of y. I think one of the most interesting properties of logarithms is that when I have the logarithm of an exponential, that exponent y comes down and becomes a multiplication out front. In other words, exponentiation inside of the logarithm becomes multiplication outside of it. And then sort of analogous to how a to the 0 is equal to 1, we can say that the logarithm of 1 is 0. And in fact, these are completely equivalent from the definition of the logarithm. So with these tools, we can again do many sort of algebraic simplifications involving logarithms. So let's look at a few examples. So here we have log base 10 of x squared times y cubed. So how do we proceed here? Well, I have the product of two things inside of a logarithm, so I can split it up as a sum outside. So I can say that this is log base 10 of x squared plus log base 10 of y cubed. Very nice. I can actually go further because now inside of the logarithms I have exponentials. So I can say that this is 2 times log base 10 of x plus 3 times log base 10 of y. Okay, so it simplifies quite nicely here. Sometimes we can actually simplify them down to just very basic numbers. So here I have log base 2 of 16. What's the easiest way to handle this? Well, you could remember exactly what this is. This is perhaps one you could commit to memory. Something else you could do would be to write this as the logarithm of an exponential. Just noting that 16 is equal to 2 to the 4. Now I can play the game of I have an exponential inside a logarithm, bring down the power to be multiplicative out front. So it suffices to compute log base 2 of 2. It is a nice exercise to show that this is equal to 1. So I just get 4 times 1, so 4. I did use an important trick here, or again, I say trick, but really you should think of it as a basic principle of how this operates, which is that log base a of a equals 1 for any choice of a. Why is this true? Well, this is equivalent, if we put it into the exponential formulation, of a to the 1 equals a. So it's just a way of restating this true fact about exponentials in the context of logarithms. And it's a nice thing to keep in mind that log base a of a is always 1. So here's another nice example. There's many ways to proceed here. I think the nicest one is to use our exponential rule first and say that this is 2 times 2 to the x, right? It's the same exponent, different bases, so I multiply the bases. 2 times 2 is 4. So I have log base 4 of 4 to the x, bringing the x out front. And now I have log base 4 of 4. What's that? Just 1. Right, so all I have to do is apply these basic principles and it will take me quite far. So here's a slightly trickier example where I'm going to have to do a bit more computation. So I have a quotient of two things that I'm taking the logarithm of. So I split it up as subtraction outside of the logarithm. So this becomes log base 2 of x squared minus log base 2 of 8 to the y. Now, it's somewhat simpler, but I would like to do even more. I'll use my exponent trick to say that this is 2 times log base 2 of x minus y times log base 2 of 8. So great, things are continuing to get simpler. And I think that there's one more natural observation to make, which is that log base 2 of 8 is simply equal to 3. So I have 2 times log base 2 of x minus 3 times y. So perhaps a little bit more complicated, but all I'm doing is applying the product, quotient, and iterated exponential rule for logarithms. Here's a nice example. I have log base 10 of x squared over x to the 4th minus x to the minus 2 plus 1. So let's start by simplifying things inside of the logarithm. We'll get log base 10 of x squared over x to the 4th is x to the minus 2. So here we just noted that x squared divided by x to the 4th is equal to x to the minus 2. And things are going to clean up brilliantly for me. X to the minus 2 cancels with x, with this x to the minus 2, so I get just 1 on the inside. And what is log base 10 of 1? Well, what is log base a of 1 for any choice of a? 0. So I just get 0. Okay, so I think this one cleans up rather nicely as well. And of course, at the end, we did have to use the fact that log base a of 1 equals 0 for every base a.